Hello and welcome to our training video on power modules and how we develop these parts to add value for our customers. My name is David Snook and I am the business lead for our low power buck modules. I will talk to you today about how power modules can help you simplify your design. Let's start with a short reminder what we're talking about. A power module is a DC-DC converter integrating control circuitry, transistors and inductor into one single package. This simplifies the bill of materials, or BOM, for your power solution and can help to reduce solution size, as you can see with both examples on the right. Taking a deeper look at the advantages offered by power modules, we see that it goes beyond the smaller solution size and reduced BOM count. They also offer significantly reduced development time thanks to their ease of use. We have characterized their thermal performance, their EMI performance, and tested them for reliability so that you don't have to. TI also offers an extremely broad choice of package options, and our portfolio of power modules covers a wide range of input and output conditions, meaning TI has the right product to help resolve your power challenges. In general, the power module market is still quite new, but it is growing very quickly and expected to reach a total market size of $1 billion by 2021. TI is a leader in this space, and we are committed to driving module technology forward by reducing package size and costs and improving performance. We firmly believe that modules will be the preferred solution for many of our customers, thanks to their ease of use and their performance in terms of power density. So we'd encourage you to think whether they fit for you and your application. The reason we believe that modules are going to be successful in the future is because of the interest we in TI are seeing today from our customers around modules. I wanted to highlight some of the applications where we have seen power modules being a popular choice. Interestingly, we see that they're covering a really broad range of applications, whether it be factory automation, avionics and defense, test and measurement, medical, grid infrastructure, or motor drive. Customers there have been asking us and designing in our power modules. If you're working on any of the end equipment I've mentioned here, then power modules should be a good option for you to consider. And I've highlighted some of our key products here, which you could take a look at. Next, I'd like to give you a few more detailed examples of how using TI's power modules can help simplify your design. The first aspect to consider is component selection. When you're choosing a discrete converter, you need to really understand the different control modes which are available. Things like voltage mode, constant on time, or decap, for example. Each of these control modes have their own specific nuances and their own aspects which you need to take care of to optimize your design. One of those key things, of course, is stabilizing a control loop, for example. You also need to think about the different features you need and how they are then implemented with this specific control topology. So all this makes choosing a discrete controller or converter quite complicated, which can be a bit confusing for non-power experts. Modules, on the other hand, make this selection process much easier and more transparent to these difficult topics. So customers can think rather in terms of input and output conditions, required feature set, and what size, what cost does their solution need to have, making it more straightforward to choose a module rather than choosing a discrete converter. The next challenge in designing your power supply is choosing the external components. For a discrete design, this means you need to choose an inductor and all the capacitors that could be needed by the device. When choosing an inductor, you obviously need to take care of the inductance, the DC resistance, the saturation current, and the frequency at which it's going to be optimized. But there are also some other less obvious topics that you need to check. You need to qualify the inductor, That means seeing how the inductance is going to behave at different bias currents and different temperatures. And you need to check that the inductor is going to respond well over a period of time with thermal aging, so high temperature storage test. There are also some other concerns with inductors, such as voltage withstand, Curie temperature, and core cracking. So all these items are reliability checks that you need to take care of when you're choosing a discrete inductor. Choosing capacitors is also not so straightforward, as you need to choose which type you're going to have. You need to think about how many you need for the device and how you're going to lay them, do the layout on the board. For modules, on the other hand, we've already integrated the inductor and usually a few capacitors as well. So this reduces the total amount of components you need to choose and gets rid of the most challenging one, which is the inductor. So we will have chosen components to optimize performance, and we will have run the necessary reliability checks and qualification tests during our development to verify they are suitable for our modules and your application. Once you've chosen your discrete converter and external components, you need to work on a board layout. This layout needs to be optimized to avoid parasitics, to reduce noise, and pass any required EMI certifications for your application. Modules help mitigate the risk of issues here with less external components, which means a simpler layout, and the fact that we have provided a recommended layout in our datasheet, which we have actually already tested for EMI. These measurements are also typically available in the datasheet or as a separate application note. So choosing a module here greatly reduces your risk of running into any EMI or layout-related issues. Once you have manufactured your board, you obviously need to characterize your power supply. In case of a discrete design, this means you need to check all possible parameters. You need to look at the efficiency, the frequency behavior. You need to check that the passive components were selected correctly. You need to check your accuracy over line transients, load transients, over temperature. Look at the loop stability. There are lots of items that you need to check out. If instead you've chosen a module, then we have already taken care of doing this characterization during our development. And we can actually provide detailed validation data for you to verify this. So choosing a module will greatly reduce your effort in characterizing your power supply. Finally, your design is completed and you're now going into production. The remaining significant challenge is managing your supply chain. This is much easier with a module design rather than with a discrete design, as the module is obviously integrating more components, reducing your need to interact with multiple vendors. We, on our hand, have been working with our vendors on our modules for the past 20 years and have very strong collaboration in place there to make sure we can keep ensuring supply continuity during production. You can also find more technical content on Power Modules available on ti.com. We have application notes and blogs covering several different topics that we know our customers care about when using our modules. The first of these is EMI and noise reduction, as we discussed briefly already. The second item involves how to use our power modules in inverting applications to generate a negative voltage. Then we have some items revolving around thermal design, and finally some content on transient performance. WebEng simulation models are also available for all of our modules, so you can quickly simulate solution for your application's conditions on ti.com, helping you make a quicker decision which of our parts is the best fit for you. This concludes my presentation. We've discussed today how Power Modules offer an easy-to-use solution for your power designs, reducing solution size compared with a discrete implementation, and simplifying your supply chain while accelerating time to market for your products. If you have any questions, please don't hesitate to reach out to us on our E2E forum at e2e.ti.com. Thank you for watching.